Hi everyone, my name is Craig and I'm going to be your host for today's webinar on Voyager. Bob Hall is going to be our presenter for today's webinar. Bob Hall is the Director of Operations for ComSpOC, a position he has held since 2014. He oversees day-to-day operations of the ComSpOC, from sensor management to data processing and customer interactions, and on-orbit threat monitoring. He has also served as AGI's Technical Director for SSA since 2007.
Thanks, Craig. Well, good afternoon, everyone. As Craig said, we're here to talk about Voyager. But before we really get into Voyager, I want to back up a second, and I want to talk about proximity operations or rendezvous and proximity operations in general. So let's talk about that. So what we're seeing nowadays, now that we're in 2019, we're seeing more and more what I call RPO, or rendezvous and proximity operations in space. Part of that is because spacecraft are becoming more complex and more capable. So you see some of the algorithmic decisions being pushed onto the space segment itself, away from the ground segment. But even so, regardless of where that control is housed, in space or the ground, we see several missions that are occurring and that are in the planning stages, whether it's prox ops, some kind of on-orbit servicing, refueling, inspection, life extension, what have you. Just a few cases here are shown. So, as I said, you might have an on-orbit servicing or assembly. Several years ago now, Orbital Express did a demonstration. We have the European Remove Debris mission, which was launched last year. It's depicted in the lower right here. They did at least one of their tests with the net. So they're testing out some of that. The DARPA robotic servicing mission is still on the books. There's been some news recently about that, although it remains to be seen how that's going to play out. But it very well may still be flown in some fashion, and so that's a mission that's going to go do RPO up against other objects. And then we have things like with the Chinese satellite, like Shenzhen 17, where it has rendezvoused and performed prox ops with several satellites. So there's a variety of things going on, and there's actually no reason to expect that this would slow down or that this is unique to the past 12 months. However, with the, I'll call it the increase of RPO missions, there's a challenge here in that modeling that mission environment and planning for all those maneuvers is very challenging. Typically, that requires a very valuable resource, an astrodynamics expert for the trajectory design. And even then, it can be time consuming. And by its very nature, when something changes with the input conditions, when the target has shifted slightly, or the launch window changes, or the mission slides to the right, or various things change, it now needs to be iterated, and in some cases built all over again. And so there's a certain lack of responsiveness and flexibility here as you go do this. So when plans change, it requires a redo or extensive amounts of work. And I would say that that's certainly more true in the operations phase. So you've spent months preparing for a mission, and everybody's familiar with what you're going to do. And you get up there, and now something's different with the target that you didn't expect, or depending on the mission, the lighting is different, or whatever changes. You're not quite in the same starting orbit you expected to be in. So now you've had to go back and almost do a little bit of a replan. And again, I'm requiring that astrodynamics expert. And as I said in some of my examples there, this is exacerbated when I have to react to what another spacecraft is doing. And that could be that other spacecraft is the target of my RPO. Maybe it's a servicing mission or whatever, but the point is that I get close enough to it and the conditions change for whatever reason. The attitude is different. It did a maneuver more recently than I expected it to do, something like that. And now I need to re-execute my plan. And so it requires that expertise. I would say that because we're seeing more of these missions, we probably, depending on our mission, we want to be more cognizant of what others are doing in space, in our orbit regime, potentially in our neighborhood. So we want to be familiar with how these sorts of operations can play out. The challenge is how do I design this mission in a way that's flexible to react to what I would call are the dynamic requirements as the situation updates, without basically taking a full-time resource like the full-time subject matter expert and parking them on my program and dedicating to that. So, because at the end of the day, I need that subject matter expertise that's in their head, even with many of the powerful trajectory design tools that are out there. That expertise is required to plan an RPO. And as I alluded to on the previous page, the question here is, what if it's not my satellite that's doing the RPO, but I still need to be able to model what's going on and potentially react to it? So what if I could take that expert and put them in a box, essentially? If I could extract the astrodynamics expertise into some kind of mission and modeling and planning tool for RPO, thereby allowing others to leverage that astro knowledge and do, I put in quotes here, routine mission planning aspect for an RPO mission. So I thereby can minimize the drain on the astro experts' time and increase their efficiency to my organization, other missions perhaps that are tugging at their sleeve, but I can basically extend my resources. And at the same time that I do that, what if I could tightly integrate the graphics in a way that communicates and enhances the understanding of these complex geometries? So if you know, or if you are an astrodynamics expert, they think in numbers. They could probably do the numbers in their head, but it's not always intuitive. If I can take some of this and present it in an intuitive fashion, it's going to let more people understand what's going on. And then if I can streamline and automate some of the mission design workflows via the graphical UI in an intuitive way, now perhaps I've gotten to the point where I've got a valuable capability that frees up some expert resources, and it facilitates the growth and empowers my mission planners in a way that I previously didn't know I could do. That type of challenge is what leads us to Voyager. Voyager is a custom mission application of AGI's, which it marries our mission modeling experience with our way of presenting graphical information, analytical graphic information. And so the way we do that is we're leveraging our trajectory design tool, STK Astrogator, under the hood. Now, Astrogator has been used in all kinds of operations analyses. At its root, what it's doing is maneuver modeling, trajectory design, and it does that via targeting, where you set up your controls and your constraints, and you can plan your mission. The difference here is I'm doing that under the hood, and I'm not requiring the operator to become an Astrogator expert for this type of application. The way we're going to do these missions, or the way we're going to model these missions, is there's three types of I'll call them maneuvering techniques. One is traditional maneuvering. Do a maneuver, move from here to there. The second one is what I call natural motion trajectories. So technically, that's the absence of a maneuver, but it's to allow the relative orbits play out in a way that gives me a natural motion between the two objects. And then the third one, which you need for a mission like this, is the ability to do closed loop force motion. So I want to move in an unnatural way, which may require me to fire fairly continuously or pulse very, very frequently that approaches a continuous firing, to achieve some sort of relative motion that is not classical orbital motion. And as we built Voyager, that part of the effort to do that was to extend Astrogator to allow that closed loop control. And then when everything's all said and done, what we can also do is Voyager will export a VDF that you could then take into STK for more detailed analysis. So you could go do your mission design and then take it into SDK to do, let's say, a communications analysis or a coverage analysis, or you want to go add some other things to the scenario. Maybe you want to make a briefing out of it. There's various things you could do, but because Voyager will export the VDF, you then have the full breadth of SDK behind you to go do subsequent analysis. So as I said, we take advantage, or we designed an intuitive user interface. The rendezvous and proxop sequences are pre-built in Astrogator. So we've done that heavy lifting, if you will, and they're part of Voyager. And then with those RPO sequences, there are sequence-specific graphical UI, for lack of a better word, I'll say widgets, that are used. The user can adjust the settings for those sequences. So I say they're sequence specific because different types of sequences require different types of inputs. And again, this frees up the Astro expert, and the mission designer can now go build these complex sequences in a drag and drop fashion. So I can present the mission in a timeline format, in a sequence format, and like I said, I just drag them onto the timeline and I build my timeline. I'm going to show you here in a minute. We're going to build a notional timeline, a notional mission. This chart I'm on here is just listing the sequences that are embedded in Voyager. They're some of the classic kind of bread and butter type of proxops sequences you want to do. And again, we'll see this in a minute when I go build a mission. Similarly, the constraints are tied in, so I can go do a sequence subject to various constraints. And so these come, again, pre-built in Voyager. I can constrain my V-bar hop based on a lighting condition, for example. This is just a quick look. If you were to take that VDF and export it to SDK and open it up, you would be able to see all these sequences live in the component browser. I'm not going to dwell on that. Here's an example of a V-bar hop. So in this example, in Voyager, we've built a far-field rendezvous, and then after that we did, looks like a couple of V-bar hops. And you notice we've expanded them here in Astrogator. You can see there's several different pieces of them. When I go build that in Voyager, you don't see any of this. You see a widget that says, tell me what type of hop you want to do, and you do it, and it goes in and builds this detailed Astrogator profile. The next few pages are just a couple of quick snapshots, but you're going to get a better view of this when I actually run the tool. So I'm not going to dwell on these. This is a far-field rendezvous. This is a V-bar hop. And again, we're going to see several of these. This is moving around in forced motion where I pick out my waypoints. And this is the storyboard view. And this is the timeline view. So let's, and this is a constrained volume that I'm trying to constrain my analysis. So let's dive in. Let's take a few minutes and go through a build. So I'm going to open up a project which is analogous in SDK to a scenario. I'm going to give it the time frame. In this case, I chose to do the better part of a month. Now I have my initial chase and target TLE. So in this case, 90,000 is my initial position of my target, and 80,000 is my initial TLE for my chaser. So I've got them for the time frame that I've built my scenario for, and here it is. And you see, as we pan around, the orange guy here is my target, and the bluish guy is the chase. I happen to know that one is inclined, which is why they look like they're not quite at the same in the same plane, but you'll see that in a second. The other thing is I skipped over when I loaded this. There was a choice to say do proxops only or do rendezvous and proxops, and you see that I already have a far field rendezvous because I chose to do rendezvous and proxops. So it's pre-populated this with a far field rendezvous. So we're going to pull that down, and then we're going to edit the far field rendezvous here in a second. So on the far field rendezvous, we hit edit. And when we edit it, we're going to see the controls that matter for that. So first thing you see is I'm going from 103 all the way to 81, and there's a pull down that says, do you want to go east or west? The page opened up east, and you see it's going the long way around. So I say, I don't want to do that. I'm going to be smart about it. I'm going to go west. And you see the graphic changed. So I'm going to go up above geo and drift west and then come down. What's my initial drift rate? Let's give it 4 degrees a day. How long before I get there do I want to do any necessary plane change? I'm going to do 2 days. And where do I want to wind up? I'm going to say I want to wind up 3,500 meters to the west, negative on the V-bar. And I hit go, and it's going and creating that far field rendezvous sequence in Astrogator. And you'll see it'll be done, and then we'll move on and build the next piece of our mission. And so there it is. You see it started out inclined, and it's moving from right to left on the screen. I'm showing you with the mouse here. And then 2 days before it gets there, we do the plane change to align the planes. And if you zoom in, you can sort of see a little bit of the last part of the far field rendezvous here. But I'm going to actually change the view to make it easier to see this. So let me go up and change the view to kind of sit on the target RSO so that it's easier to understand, easier to follow what we're doing here. The other thing I'm going to do is, just like SDK, there's a lot of the same types of controls. I am a big fan of the unconstrained view, so that's what I'm going to use here. It's the one I'm most comfortable with in terms of maneuvering the window around. So here's my target that I'm going to go after. And there you see the far field rendezvous swoops in and parks. We're going to turn around here so we can look at it in the nadir direction. So it swoops in from the from the east and parks on the west-hand side, about 3.5 kilometers away. Let me zoom out so it's on the screen. There it is. So okay, so we did the far field rendezvous. Now, next thing I want to do is one of the things you can design your own mission, and I don't claim to be the RPO mission design expert, but this is the way I like to do it. Once I finish that rendezvous, I at least want to coast for a little bit. So I'm going to put in a half a rev coast here. So I get there and I kind of stop and park for a little bit. Okay, so after that, now let's start to do some interesting things. Maybe we will we'll do let's say a V-bar hop. So we're 3.5 kilometers away. Let's do a V-bar hop. So I drag a V-bar hop in, and now you see over here I can do I want to go towards or away? We want to go towards. I'm going to toggle that little pull down now. And now I can either type in a number or I can drag the little graphical widget. And notice as I drag it, the number's changing. So I can just drag it and say, be done with it. That's what I want to do. If, on the other hand, I have a reason to be precise, and sometimes I tend to be precise, I'm just going to type the number in here and say, hop 1,500 meters. And there you go. You see the course rendezvous stopped, it dwelled, and then it did a 1,500 meter hop, leaving us still 2 kilometers away. So I'm going to go through several pieces of this design here as I play with the various sequences that Voyager has. So now I'm going to do an offset circumnav. So offset circumnav, it looks like a circumnav, except it's not centered on the object. And I told it how far away to stay. I kind of clicked through that fairly quickly and maybe didn't point out how far I chose. But there's in pink the little offset circumnav. Now I'm going to do another type of circumnav with a close approach. So this one is going to say, how close do you want to get? I'm going to choose 100 meters, except I'm going to do it on the west side. So I said minus 100 meters. And you notice now I have a new sort of circumnav, and I come within 100 meters of the target. However, these circumnavs are integer number of revs of circumnavs. So when this sequence ends, you see this sequence that we just added, the last one on the right, my chaser winds up back at the starting point. So since I really want to kind of move my mission along and start to creep a little closer to my target, I'm going to now put in a pure V-bar hop. So let's drag a V-bar hop in, and again, I can drag and drop. I'm going to flip it to towards, not away. Hang on a second. Yeah, because otherwise I'm going to shoot myself in the foot and go the wrong way and say, why did I do that? So let me do towards. I want to get really close. Let's say I want to get maybe within about 100, 150 meters or so of the target. I knew I was 2 kilometers away, so I'm going to go 1,900 meters. And there you go. And you notice that the hop ends up right there. So there's my chaser and my target. And I'm going to continue to make up some fictional crazy mission here. So now let's what should we do next? Let's maybe I want to plan to do, before I do anything else, let's just do a pure vanilla circumnav around the target. So there's no value to adjust here. It's from wherever I start, do a circumnav. So this is the classic 2x1 circumnav I see. 2 in the in-track and 1 in the radial, if you will, the shape of that oval. Having done that, now I want to start to do some crazy stuff. So I'm going to start to do I want to go do some forced motion things. But before I do that, I want to hop to some random arbitrary point. So I'm going to go to some arbitrary point relative to the target. And here I have a little graphical widget, and I have numerical fields. So again, because I like to put in precise numbers, I'm going to put in a number here. I'm going to line up exactly on top of it from an in-track perspective. I'm going to give it some radial offset and a little bit of cross-track offset, 125 meters and maybe 200 meters. Going to dwell there for 2 hours. Going to take 2 hours. And now if I zoom out, you'll see there's that hop to that random point I just gave the UI. So what you see here is I'm building this completely notional mission, but I'm building this mission to affect a rendezvous and proxops mission timeline. Let me just carry this on a few more minutes and do some crazier things, and then we'll get out of Dodge. Before we do that, I'm going to do some forced motion, and in this case, I'm going to give it some points in space around the target and say, go here, go here, go here, go here. And so I'm going to add those points. I'm going to click out those points and tell it where I want to go in sort of 3D space. And we're going to run actually a fuzzy logic controller under the hood with the engine and astrogator to affect these orbit changes. And then once I'm done clicking through these various things, actually I have 2 monitors here, and I'm going through that on the other monitor. And so once I'm done, you're going to see that kind of wacky path that I picked pop up. You see a little bit of it showing up there. I'm going to say OK. And it's going to go run the fuzzy logic controller with my engine model and compute the maneuvers. And now if I zoom out, you see this kind of ridiculous profile that I just haphazardly chose. So again, I'm presumably, as the mission designer, I have some particular path or space with respect to the target I may want to be. And again, I can layer in constraints and say, I want to be in a place where, maybe only do this when we're not lit, or that type of thing, or the ground is lit, so he can't see what I'm doing, type thing. So after my force motion, I'm going to hop back to some other point. In this case, I'm just going to go back to the V bar. I'm going to sit 125 meters to the east of it, because I'm starting to think about my egress at this point. So let me get back to a stable point and hit go. And you notice every time I do this is all very quick, very quick, very quick. And the graphical interface is really easy for me to do this. And I didn't have to know in Astrogator how to do a hop to an inspection point or a V-bar hop or any of that stuff. So now I think the next thing I'm going to do, let me think about maybe a V-bar hop, because again, I'm thinking about getting out. But before I do that, let me try and stop my relative motion. Again, this is another sequence that we have that lets you kill the relative motion at that instant in time. Now, it's an instant in time. And if you then go propagate, guess what? Wherever you left off, you're going to start to walk away from. And if I zoom out here, you'll see a little bit of that. And then let's try and wrap this up. Maybe I'll do a V-bar hop, and excuse me. Then I want to do a safety ellipse. Let's back away, and then I'll do a safety ellipse, and then we'll depart. So let's hop a couple of kilometers away, maybe. Maybe that's too far. Maybe we'll just do fraction of a kilometer to keep it all in the same view, and then we'll do a safety ellipse. So let's do that. So let's drop in a safety ellipse. So something's happened. I want to be in a mode where there's really no risk of recontact. Best practices. Before I go do something like that, let me coast. In my own personal best practices, I don't like to do crazy sequence into crazy sequence into crazy sequence. Let me just coast for a little bit, and now let's do a safety ellipse. Safety ellipse again being a thing where I know there's virtually no risk of recontact because I've got some cross track and radial separation, and I can decide what the angle of that kind of inspection is as I go around. Except I think in this case, let's zoom out and notice I was a bad mission designer. I designed my safety ellipse to walk away from the object instead of walking right by it. But you get the point here. It's based on where I started. I entered a safety ellipse, and then if you notice, I've got a cross track and a radial separation. So finally, let's just exit the area, and this is going to do sort of the complement to the initial far field rendezvous. It's not going to do the plane change because I'm not asking for that. But what's the drift rate I want to be at? Let's say 2 degrees a day, and let's propagate 3 days worth of that, and then just like that. So I've spent, all told, about maybe 14 minutes designing this mission, and it looks like it. So it's some wacky thing I just made up, but it was that easy. I can layer this. I can put in constraints. Let me just show you very quickly the timeline view. So now, instead of the sequence palettes that you saw there, I can switch to the timeline. And notice up top, this timeline is very similar to the timeline you see in SDK these days. So I can expand it and shrink it. And now you can see each of the sequences and how long it took for my spacecraft to execute that sequence. Sometimes they're short, sometimes they're long, because sometimes it takes a while to go from point A to point B. So again, it's another way to see what's going on. So again, that's a really, really fast run through of I'll say a wacky mission design, but you saw just how easy it was for me to do that. And I didn't have to go get my trajectory design guru to say, hey, how do I hop to a random point? How do I do a V-bar? How do I do this? I can just do it. And then if he needs to come and check the work or take the scenario into SDK, he or she can do that. So there are analysis capabilities just like any of our other products. I can get a 2D view, a 3D view, graphs. I can look at fuel usage, maneuvers, duty cycle, access times, all sorts of things that's listed here. And I didn't dwell on animating it. If you noticed in the upper corner where was the animation toolbar, so when I'm all done, I can play the thing. Like I said, I can export a VDF and go do further analysis. So that was a really fast run through. And it seems like we maybe have some questions coming in.
Yeah, there's a couple good questions out there. If we want to take a second to ask these, some of them I answered privately, and some of them I think they're good for the group. One general question was, does Voyager support different kinds of propulsion, specifically low thrust?
I believe that you can put your engine model in the default scenario. You may have to go in and change the template ahead of time. So I want to double check on that one.
Okay. And then there were a number of questions that asked about the ability to customize the RPO sequence, for example, to make it do a teardrop type R-bar hop. And for example, option, and a couple of other ones similar where you want to do a very customized sequence. Can you do that in Voyager, outside of Voyager, and bring it back into Voyager?
You can. So there's two pieces of that story. So one is the sequence itself, and this is a case where you could leverage that astrodynamics expert to go into Astrogator and go build those sequences in such a way that they're going to work for you. I mean, part of the I'll say the beauty here is that these sequences had to be fairly robust so that when you change things, they converge. So if you have a new sequence, you would do that, and then you might need to extend one of the UI pieces, because depending on what sequence you build, it may need different inputs. So we would probably want to talk to you about that.
All right. There's a couple of other questions I'll try to address towards the end. Maybe one last one. Can a delta V budget analysis be done using Astrogator?
Yeah, you can get the whole fuel summary, the whole delta V summary, and say, what did this take? And say, well, that's more than I have, or that's great, and do those what if games.
Can you get that summary?
You can get a report.
Okay, and we'll see that towards the end when you talk about how this integrates with Astrogator.
No.
Okay. All right.
I wasn't planning to call up reports.
Okay, over to you.
All right. So that, again, it was a fairly fast run through of Voyager. Hopefully it gave you a sense for what it does and how easily it does it, and frees you up to do more powerful things. There's a few more questions here. So one is, how do you set up the initial orbit? Because I kind of flew through my demo here. I chose to use a TLE. You can load in an initial ephemeris file or a TLE. So I started with a TLE for my chaser and a TLE for my target. Let's see what else. There's a question about a safety orbit. I think the safety ellipse, which again gives you that radial and cross-track separation in a way that you're not going to contact, is the way to do it. So you could say, imagine you have the whole sequence built and you're running it, you're executing the mission, and you say, oh no, we need to get to a safe place. You can drag, and I didn't do this in my demo, you can drag and drop a sequence in between other sequences. So you may not have planned that safety ellipse. You may be executing all the little things you want to do, and you say, stop, let's do a safety ellipse. You drag it down right now, and it'll show you how to transition to it. So this is another question: is how close to docking can it support? So you've got to be careful here, because one of the things I did is I was propagating my target. So there's a point in a docking mission when you really need to precisely understand the target, and that may not be a propagation of an orbit solution. In other words, if I really was going to do docking, there's a point in the mission where I probably want to transition to onboard closed loop control. So I can take it, I can plan it to all the way down to 100 meters and park, and say, I'm going to park at 100 meters, and I'm going to then hand it over to the onboard controller. I wouldn't advocate getting extremely close, again, because now you have all the potential propagation errors that could exist, and you have to allow for uncertainties in where the target might be. I think maybe the rest of these, I'm trying to read them as we go. Maybe the rest of these I would go through offline and try to answer.
Well, one thing that we did forget to mention, though, that the other products mentioned in today's webinar, one is Voyager and the other is Astrogator. So we just forgot to add that to the slide, but it is Astrogator that is used. So I want to thank everyone for joining today's webinar. For those questions that we didn't get to, we will be answering those individually after we sign off. We are also going to be sending a recording of the webinar to everyone, and we'll be posting it on our Analytical Graphics YouTube channel. All of our past webinars and our new Tech Talk series are also on our YouTube, so just be sure to check that out. I want to thank everyone for attending, and I hope to see you at another webinar in the future. Thanks.